Alright, let's talk about torque. Simply put, torque is a twisting force. Think about opening a stubborn jar lid. That twisting effort you're applying, that's torque. It's a force that causes something to rotate around an axis. Now, the clever bit about torque involves something called a lever arm. Imagine you're using a wrench to tighten a bolt. A longer wrench makes the bolt easier to turn because the distance from where you apply the force to the bolt, the pivot point, matters. This distance is your lever arm. A longer lever arm means you can achieve the same torque with less force. Torque is calculated by multiplying the force you apply by the perpendicular distance from the pivot point. Force times distance. If there's no distance, or if the force is directed straight at the pivot, you get no torque. From tiny gears in wristwatches to colossal engines in ships, torque is fundamental. Without torque, things would be pretty stationary. So, we know torque is a twisting force. In the metric system, the common unit for torque is the Newton meter, written as Nm. 1 Newton meter is the torque from a force of 1 Newton applied perpendicularly to a moment arm 1 meter long. In the United States, you might encounter pound-feet, written as lb/ft. Torque is a vector quantity, meaning it has both magnitude and direction. The direction is typically described as either clockwise or counterclockwise. Engineers often use the right-hand rule, curl your fingers in the direction of rotation, and your thumb points in the direction of the torque vector. Controlling the direction of rotation is critical in machinery. Think about tightening a bolt. You turn it clockwise. An engine needs to turn a crankshaft in a specific direction to make a car move forward. Knowing both the amount of torque and its direction is essential for designing and operating machines correctly. Torque is not just some abstract concept. It's what makes machines do useful work. It's the muscle behind the motion. You see its effects everywhere, from the vehicle you drive to the tools you use. Without torque, the gears wouldn't turn, the wheels wouldn't spin, and heavy objects would stay firmly on the ground. It's the fundamental turning effort that translates into action in the mechanical world. We rely on it constantly, whether we realize it or not, for a vast array of tasks that make modern life possible. When you press the accelerator in your car, you're telling the engine to produce more torque. This torque is the twisting force that the engine applies to the crankshaft. This rotational force is then transmitted through the drivetrain to the wheels. The more torque an engine can produce, especially at low engine speeds, RPM, the quicker the car can accelerate. Diesel engines produce a lot of torque at low RPM, making them excellent for heavy-duty applications. Gasoline engines in sports cars might produce peak torque at higher RPMs. Automatic transmissions use a torque converter to smoothly transmit power from the engine to the transmission. Gearboxes or transmissions manipulate torque and speed. They take the torque produced by an engine and modify it to suit different conditions. When a smaller gear drives a larger gear, the output torque is increased, but its rotational speed is decreased. Conversely, when a larger gear drives a smaller gear, the output torque is decreased, but its rotational speed is increased. Gear ratios are the heart of a gearbox. Engineers select these ratios to provide a spread of torque and speed options. For a car, this means having low gears for strong acceleration and high gears for fuel-efficient cruising. For industrial machinery, gearboxes might slow down a high-speed motor while increasing its output torque. Cranes are a perfect example of machines where high torque is essential. The motors in cranes generate very high torque, which is amplified by gears and winches before being applied to the lifting cables. The long arm of a crane acts like a giant lever. The further the load is from the crane's pivot point, the greater the torque it exerts. To prevent tipping, cranes use massive counterweights. These counterweights create an opposing torque that balances the torque from the load. The slewing mechanism, which allows the crane to rotate, also requires significant torque. Hydraulic or electric motors provide this rotational torque, allowing precise positioning of loads. People often use the terms torque and power interchangeably, but they are not the same. Torque is the actual twisting force, while power is the rate at which work is done. Power is equal to torque multiplied by angular speed. High torque is what you feel when you accelerate hard from a standstill. High power contributes more to a car's top speed and its ability to accelerate at higher speeds. Both are important, but they tell different parts of the story about an engine's capabilities. Understanding the distinction is key. Torque can be categorized as static or dynamic. Static torque is the twisting force applied when an object is not rotating. Think about trying to loosen a rusted bolt. Dynamic torque results in angular acceleration, meaning the object is rotating and its speed is changing. When you step on the gas pedal in your car, the engine produces dynamic torque. Most of the time, when we think about engines doing work, we're thinking about dynamic torque. Both static and dynamic torque are crucial in different scenarios. For mechanical engineers, understanding and calculating torque is fundamental. Engineers must ensure that components can transmit or withstand the required torque. Consider a shaft transmitting power from a motor to a gearbox. The engineer needs to calculate the torque and select a material and diameter for the shaft. The entire system must be designed with torque in mind. From robotic arms to wind turbine blades, torque calculations ensure functionality, durability, and safety. It's truly the backbone of robust mechanical design. So there you have it. Torque is a twisting force that makes things rotate around an axis. It's a straightforward physical quantity that we can measure and calculate. Torque is measured in units like Newton meters or pound-feet. Torque has a direction, usually clockwise or counterclockwise. Knowing both the magnitude and direction of torque is essential for any practical application. Torque is the raw twisting ability, while power is the rate at which that torque can do work. Static torque is a force trying to cause rotation without movement, and dynamic torque causes an object to accelerate its rotation. Engineers live and breathe torque calculations to design safe, efficient, and reliable machines. Don't underestimate the power of the twist.